Saxon Algebra 1, Lesson 37, Inequalities greater than and less than, Graphical solutions of inequalities. We use these symbols, that's not equal to, greater than, less than, to designate that quantities are not equal. And we say that these symbols are symbols of inequalities. They can be read from left to right or from right to left. This can be read as 4 is not equal to 5, or as 5 is not equal to 4. The symbols greater than and less than are inequality symbols and are also called greater than, less than symbols. The small or pointed end is read as less than, and the big or open end is read as greater than. When we read only one end of the symbol, the end that we come to first. For example, if we read this from left to right, it says 4 is greater than 2. If we read it from right to left, it says 2 is less than 4. If the sign is combined with an equal sign, then we read the symbol as less than or equal to, or as greater than or equal to, depending on which way we read, left to right or right to left. For example, if we read this one from left to right, it says 4 is greater than or equal to 2 plus 2. If we read it from right to left, it says 2 plus 2 is less than or equal to 4. This combination symbol is also called an inequality symbol, although half of it is an equal sign. Inequalities can be false inequalities, true inequalities, or conditional inequalities. In the following list, those highlighted in red are false inequalities. If we read from left to right, the first says 4 plus 2 is less than or equal to 3, and that's false because 6 is not less than or equal to 3. The second one says 4 plus 2 is less than 6. That's false because 6 is not less than 6. And the one at the bottom there says x plus 2 is bigger than 3 plus x. That happens to be false because if you add 2 to a number, you're not going to get anything as big as when you add 3 to a number. Those highlighted in green are true. In the upper right, we have 4 plus 2 is less than or equal to 6. 6 is equal to 6, so it happens to be true because it has a less than or equal in it. And the highlighted in yellow inequalities are conditional because they depend on what x is. If a number that we use as a replacement for the variable makes a conditional inequality into a true inequality, then we say that number is a solution of the inequality, and we also say that number satisfies the inequality. Since more than one number will usually satisfy a given conditional inequality, there is usually more than one solution to the inequality. We call the set of numbers that will satisfy a given equation or inequality the solution set of the equation or inequality. We use the number line to help us picture the way real numbers are ordered, ranged in order, and to help us define what we mean by less than or greater than. We say that a number is less than another number if it lies to the left, and we say that a number is greater than another number if it lies to the right on the number line. For example, -5 is less than 3 because it is left of 3. And 3 is greater than -5 since it's on the right of -5. We draw number line graphs of solution sets to inequalities by shading that part of the number line that contains the solutions. With strict inequalities, that is, inequalities without an equal sign, we use an open circle at an endpoint where the solution set ends to indicate that point is not included among the solutions. For example, the solution set to the inequality x greater than -3 would be graphed as shown here. The open circle around the -3 means that's not one of the numbers in the solution. And the shaded part on the right indicates that all numbers to the right of -3 are solutions. When an inequality includes an equal sign, then the endpoint will be included as part of the solution set, so we would use a solid circle in the number line graph. For example, the solution set of the inequality x less than or equal to 2 would be graphed like this. The solid circle indicates that 2 is a solution, and the shaded part indicates that all numbers left of 2 are also solutions. Let's test your understanding. State an inequality with x as the variable, which has the solution set graphed. What do you think this is? You could say x is less than -2. Or you could say -2 is greater than x. How about this one? It has a solid dot at -5. You could say x is greater than or equal to -5. Or if you talk about -5 first, you could say -5 is less than or equal to x because -5 is left of the shaded part. This is the end of lesson 37. Your assignment, problem set 37 on pages 151 and 152 of your book.